Okay. All right. Okay. So, do you guys have any questions about this example?
That 1.562 is supposed to be 0 minus 1.562, right? Right there.
Right there? Yes. But yeah, sometimes I always got confused about positive and negative, so I always like to keep both sides positive. So when I look at the plot, I know where it is, right? If it's below x-axis, it's negative, right? And if it's above, it's positive. So, all right. So either way is fine, as long as you get the right diagrams. Okay. All right. Now back to my question. Why we need to do this? Why we have been spending? Did you guys do this in statics, by the way?
Yeah.
Yes. Okay. I know you did this in mechanics materials, possibly, right? Why we need to do this? For fun, try to get an A for the class. It's required. Okay. It's because of this. So, like I mentioned, when we do this free body diagram or shear force bending moment analysis, there's one information we can get. Tells us what's the maximum shear force existing in the beam and where the maximum shear force is at, right? For example, this case tells us, oh, the maximum shear force is minus 7.5 and existing from point B to point C. Also, it tells us the maximum bending moment is 37.5 and existing at exactly point B. Now, we know the maximum shear force and maximum bending moment. Chance is I can use this for my Figley analysis. When I analysis a beam or shaft or wheels of a vehicle, I know where the maximum shear force is. So possibly I know when I design it, if the maximum shear force is applied is over here, possibly I need to make sure the materials at the point B has to be strong, or maybe somehow when I design it, when I go back and redesign it, possibly I should make this section of B a little thicker. Make sense?
Mm-hmm.
That helps you to design your system. Now you get it?
Mm-hmm.
Some of you? Those of you sitting back don't care. I'm talking about you, look at your computer, what are you doing? Okay, all right. Anyways, well, I typically don't like students to look at your laptop while I'm teaching because you don't need it. All right, so if you don't need it, try not to look at your computer. Okay, all right. But if you have to look up something up, feel free. Okay, all right. Yeah. So that basically tells you when you have a shear diagram and a moment diagram that help you to design, help you to do analysis. You know exactly which point is experiencing the most shear force, which point is experiencing the most of the moment diagram, right? Those are the points possibly failure will happen. Make sense? Now we know, huh? Okay, good. Because the reason why I asked you guys is when I was a student, I always ask myself, hey, why I need to do this? Like, what's the point of solve these nonsense numbers? What I can use it for in the future, right? And after I graduate, I guess I did, huh? I look back, I see, oh, now I see why it's important. Now I see why I'm learning this, okay? So I want to share the same experience to you guys so you have better understanding, the big picture of this stuff we're learning, okay? All right. We have class until 4:20. Okay. Let me do another quick example. How's that? No? Nah. I promise it'll be 5 minutes. How's that? Okay, so you have R1 and R2. And this time we'll use English unit. And if you have 4-inch, then 6-inch, then 10-inch, then draw to scale. And I ask you to do the free body diagram and look for the moment and shear force. Okay, first of all, we need to solve for the unknowns. So R1 plus R2 is equal to, oh sorry, this is 200, not 20. $200 plus 100, and 200 times 4 plus 100 times 10 equals to 20 times R2. This is because summation Fy0. This is because summation, let's say this is point A, MA is 0. Okay, so R1 is 210, R2 is 90. Pound force, pound force. All right. Okay, this example is relatively speaking very easy. Okay, so you have R1 210, R2 90. Then you have 3 forces on it. Sorry, 2 forces on it, 200 and 100. 200 and 100. You have 4, 6, and a 10. Right? Okay, shear diagram. Now should be really easy for us. 210. Initially 210, right? Hit 200 concentrated force, drop down, keep on going, drop down, 290, and it goes back. So this is 210. This thing over here is 10, and over here is 10 minus 100, negative 90. So this thing is 0. Right? Make sense? Okay. I said it 5 minutes, right? I still have 2 minutes, okay? And it was still 3 minutes early, huh? Okay, so M initially increase, and then slowly increase, then decrease, back to 0, because we know it start with 0, go back to 0, right? Now, if you want to calculate what's the value here, what's the value here, what's these two values, is just the area, right? So that's easy. Okay, that's pretty much it. So we know maximum shear force is 210 from here to here. Maximum bending moment is right here at this point where the second force is applied. Okay, these are the points we care the most when we do mechanical design. Okay, all right. So it seems like it only took me 4 minutes, huh? Good. Up. Huh? Go up? Sure. There you go. Huh? Go down? Sorry. I should have taken 10 minutes, huh? Let me do it this way. How's that? Okay. Alright. After you copy all the lecture notes, class dismissed. I'll see you guys on Thursday.
Yeah.